Got some other practice stuff. I don't think I've handed that out yet. Okay. All right, so here we go. I did not fill in the chart, right? Mine's filled in on my paper, but I don't think it's filled in for you. So we need to be able to figure all that out. So let me set my chart up here. Okay, so what's happening? Paul's diet is to contain at least 24 units of carbohydrates and 16 units of protein. Food substance A costs this and has this much. Okay. So I need carbohydrates and protein, and it's going to come from food substance A or B. All right. And I am trying to do this to minimize cost. All right, so here we go. Paul's diet is to contain at least 24 units of carbohydrates. Where does that 24 go? The total carbohydrate. And 16 protein. Food substance A costs $1.40, so right here. And B is 90. Oh wait, $1.40, and each unit of A contains 3 carbohydrates and 4 protein. Oops. Each unit of A is 3 carbohydrates and 4 proteins. Does that make sense? And B has 2 carbohydrates and 1 protein. How many units of each substance? So I'm going to let X be the units of A, and Y will be the units of B. Those are my unknowns, my variables. Now, is there anything about that you're not sure about? Is there anything about that we need to talk about? Okay, then I'm trying to minimize cost. How will cost be calculated? $1.40 for every X and 90 for every Y. Okay, now we don't graph that one. Remember, the thing that you are maxing or minning, we're not going to graph him. We're going to use him later. All right, what are my constraints? What are the equations or inequalities that I'm actually going to be graphing? What do you think? Right there's one. That's a constraint. What does that say? What's that row say? 3 x's plus 2 y's is at least 24, which means greater than or equal to 24. Now, that's important because remember, we're going to be shading, and we're going to shade based on that sign. So make sure at least 24 means greater than 24. And then 4x plus y greater than or equal to 16. And then you don't really have to add these, but feel free to because they are constraints to the problem. But I've already accounted for them by setting up a graph that looks like this. So there we go. Okay, now we're going to sketch it. I can probably use a scale of 1 on this one. That's up to you. You can pick it, but I think I'm just going to use a scale of 1 here. So, remember how we do this. intercepts. So cover up X, Y would be 12. Cover up Y, X will be 8. And connect the dots. Everybody okay with that? And shaded out. So this out here is shaded. All right, now this one, same thing. Y is 16. And X is 4. Shaded out. So the area that is shaded above green and above red would be this area right here. Would everybody agree with that? Bounded by the point 016, the point 80, and that one. How do I find that point? It's the intersection of red and green. So the mathematical way of doing it, not just eyeballing and guessing, but the mathematical way is to solve this system. Guys, why are you staring at me blankly? We did this a whole bunch the other day. We're solving this system to find where the two lines cross each other. And you can solve it however you want. I'm going to multiply this one by -2, because I always eliminate almost. So I got -5x equal to, what is that, -8? So x is 8/5. 1.6. Anybody already do this? Oh, here, I can check. Yep, that's what I got. So x is 1.6. And then I'll plug that into one of my equations. It doesn't matter. So I'll just put it in this one. So 4 times 1.6 plus y equals 16. So I got 9.6 for y when I just solved that. So there are my 3 potential answers. 016, this guy, and 80. Is everybody clear on that? There's your vertices. One of those is going to give me my minimum cost. So, one at a time, I'm going to take the x and the y and plug them in here. This is my cost equation. So 1.4 times 1.6 plus 0.9 times 9.6. That one's going to be 1088. So to get all my nutrients, it's going to cost me 1088 with that plan. 016 is 1440. And 80 is 1120. So what am I gonna buy? 1.6 units of A and 9.6 units of B. Don't let the fractions bother you. If the units happen to be pounds or something, can you buy 1.6 pounds of something? Sure. Yeah, I'm not worried about that. We good? Okay, so everybody who's here is gonna get credit for the homework. Please do not turn it in. Do not turn it in. I just did it. I don't need to look at it again. All right, so everybody who's present is gonna get that. Those not present will have to turn it in. Okay, so I promised you that. Okay. Now. I want to get back some other homeworks. Tomorrow, I'm going to pass back the quiz because by tomorrow, everybody will have taken it. While I'm doing that, would you get out, didn't I give you a review packet the other day? All right, I did get that out. And we're just gonna look at the very front page of it, not because there's anything special there, just some random review. Now, as I am turning back stuff, if you have a question, we'll take that too. Let's get through this review page first, and then if you have questions about something. Questions, as soon as we get through this page. So if you've got something on one of these pages, then
yeah, it's a bird dog. Oh yeah, they suck. Gotcha, that really explains how they are.
all right. We're almost done. I'm kind of curious in there. It would be worth it.
So you can buy a dolphin.
I probably would. Not sure what I would do with
Put it in
it.
your classroom. Duh.
Put it in my classroom.
Of course. It's like good luck if you touch it before you get a good grade.
I had my stick. So
Yes.
maybe. No, it's behind the doors. No, I swore I'm not getting rid of the stick. Not sure what I'm ever gonna do with it, but we got it. All right, I think I'm done. Almost. One more. All right, here we go. We're doing, this little review sheet, and then I'll take whatever questions you want. All right, number one. Find the partial fraction decomposition. Okay, who remembers the steps we need to go through for this? Factor the bottom. All right, so that's gonna be step one. We're gonna factor the bottom. bottom factor. X minus 2 minus 1, right? So then what? That's step 1, absolutely. Then what? We gotta make 2 smaller fractions. One will have a denominator x minus 2, and one will have a denominator x minus 1. Guys, it doesn't matter which order you have these in. Your final answer will come out the same. Okay, it doesn't matter. So I got this one and then that one, an A and B. I don't know what those are, but that's what I got. All right, what's next? Multiply everything by the common denominator. So the common denominator obviously would be this. So I'm gonna multiply everything. I always write it down. You guys don't need to. If you can do it in your head, that's perfectly okay. But understand what's happening is the denominators are all going to cancel. That's why you do this. So they all cancel, leaving me here with ax minus a, and here with bx minus 2b. So the fractions are now gone. All right? Now what? We understand that since this is an equation, however many x's you have on this side, which is 4, has to be exactly the same as the x's on that side, which are a and b. Whatever these numbers are would have to total up to 4. And likewise, this guy, which doesn't have an x, has to be the same as this guy and this guy added together. Now this will solve this system, and it's kind of set up perfectly for elimination. I mean, that's just chance, it happened that way. Somehow you have to solve this system. So using elimination or substitution or Cramer's rule or something, solve it. I'm gonna go ahead and just add them. So negative 1 equals negative b, so b must equal 1. And if a and b add up to 4, but b is 1, then a is 3. Now, the answers are not A and B, because your A and B will be different than my A and B if you have these things turned around. The answers are the fractions. So for me, my fractions will be 3 over x minus 2 and 1 over x minus 1. And that will be your fractions no matter how you set the problem up. All right? You're going to end up with 3 as the number over x minus 2. Whether you call it A or B is irrelevant. 3 is going to be over x minus 2, and 1 is going to be over x minus 1. So that's the answer right there. Find the partial fractions right there. Got it? Okay. Well, B is the same thing. I'm not going to do that one. Let's do the bottom. It says solve using Cramer's rule. Now it's exactly what happened here. This time it was A and B, but it's the same as getting an X and a Y. But it says I have to use Cramer's rule to find those 2 values. Here I used elimination. So how does Cramer's rule work? You have to get the determinant of the coefficients. So these guys are nicely lined up. So 2, 1, 3, negative 2. That's step 1. We're going to evaluate that determinant, the determinant of the coefficients. All right? How do we do that? How do we find a determinant? We multiply these two together and get -4. We multiply these two together and get 3, and then what do we do with those two numbers? Subtract. So the value of the determinant is -7. Now, what is the significance of the -7? What does it have to do with anything? It is not the answer. No one remembers what I do with the -7? Eli? So whatever x and y are, remember this is what I'm looking for. They're gonna be fractions and they're over -7. That coefficient determinant is the denominator of your answers. So how do we find the numerator of the answers? We build two more determinants. Whichever one we're doing, we take these two numbers right here, the constants, we cut them out, and we paste them on top of whichever letter we're solving for. So in the original determinant, these were the x's, these are the y's. If I'm solving for x, I'm going to cut these out, and I'm going to paste them right here. So what does that determinant look like? 7, 9, 1, -2. Cut these out and glue them on top of the letter that you're solving for. So when I do y, I'll cut these out, but I'll glue them here. So that will be 2, 3, 7. So now I'll evaluate those determinants. So go ahead, you do that. Tell me what these two determinants equal. What do they equal? X is -23, -14 minus 9, -23, perfect. Y is?
-3.
18 minus 21, so -3. Now, you are always, of course, responsible for simplifying whatever you end up with. So in this case, there really isn't anything to do except we don't want all these negatives in there. The negatives are going to cancel, so that would be the answer to the question. Okay? All right, now we're going to do the one in the box, which says find the area of the triangle. This is one of the coolest things. This just makes me so happy. Who remembers this? I think we only did 1 or 2 of these guys. Anybody remember what we do, Meg?
Create a triangle and then pick a point and then subtract from the other points.
So 1, -2. And I'm not gonna waste time plotting them, but you could if you wanted. Like if you wanna actually set up a grid and do that, you can, but you don't need to. What you need to do is exactly what Meg said. You need to figure out, pick a point, I'm just gonna use A, use whatever point you want. Pick a point, and then say to yourself, all right, how do I get from A to B? That's called a vector, you don't need to know that, but how do I get from A to B? How am I moving? Well, for X's, I'm going from 1 to 3, which is 2. And for Y's, I'm going from -2 to 4, which is 6. So that's how I'm moving from A to B. Do X, do Y. Then move from A to C, so that you're emanating out from a point. So you can come out, you can do CA and CB, or BC and BA, doesn't matter, just pick a point and come out. All right, so what's AC? From A to C. Watch it, that one would be -2. You gotta pay attention to the signs, positive and negative. And then from -2 to 1, 3. Okay, so we picked a point, A. We found the directed distance, the vector, from A to B and from A to C. All right, now what? Put them in a determinant, and you don't change a thing. You literally put them in a determinant. So 2, 6, negative 2, 3. All right, so what's the value of that guy? 18. 6 minus negative 12, 18. And then what's the last step to get the area? You have to divide that number by 2. So the area of this triangle is 9. Slick, slick, slick. Okay, now, look, you got our whole packet. We'll look at one of the review sheets in a minute, but first, are there any homework questions? I handed back, I think, all the homework papers that I have. Any questions from an assignment? I marked something, and you're not sure what's going on. Page?
On 7.3, number 2.
7.3, number 2. Now, I just did this system right here. I solved this system using Kramer's rule. So I have that process for Kramer's rule. This question on 7.3, number 2, gives me exactly the same kind of problem. The equations are different, but it's the same kind of problem. And it says, solve using the inverse method. All right, so that's just another procedure that you got to remember. You remember the Kramer's rule process. Now, what is the inverse method process? Well, you start actually the same way. So we're going to find the determinant of the coefficients. So 1, 3, 3, negative 1, we're going to find that determinant. What is that? Negative 10. Negative 1 minus 9, negative 10. Okay? Now, we're doing the inverse method, so we have to find the inverse of this matrix. So the first step to finding the inverse is doing the determinant. We've done that. Now we're going to build a new matrix. And remember how we do that? We build it by switching these two and changing the signs on those two. Right? And then we take that guy right there and divide everything by negative 10. So the inverse matrix is 1/10, 3/10, 3/10, negative 1/10. That's the inverse matrix. That's not the answer to the question. That is the inverse of the coefficient matrix. To get the answer to the question, you simply take that matrix and times it by 7/1. That's how you do the inverse method. You find the inverse of the coefficients and you times it by the constants. So, what are the dimensions of this guy? 2 by 2. What are the dimensions of this guy? 2 by 1. So I'm going to multiply them and end up with another 2 by 1. That's going to be my x and that's going to be my y. So take these numbers times these numbers. Row times column. So 1/10 and 3/10 times 7 and 1. 7/10 plus 3/10 is 10/10, which is 1. And then this times that, so 3/10, negative 1/10, 7, and 1. So this would be 21/10 minus 1/10, which is 20/10, which is 2. So the answer to the question is 1,2. All right, so what we've done here now is actually this morning so far, we've taken a system of equations that look like this and we've solved it 3 different ways. Our first time, I just did elimination on it. Then we did a Kramer's rule, now we're doing an inverse. They all accomplish the same thing. They all find a point where we cross. It's just what process we're using. Okay? Good review. Okay, what else? Anything else on a homework paper I returned? Abe?
Can you do number 3 on 7-4?
7-4, number 3. We're sketching and labeling all the stuff that we normally label. So the problem is this. Okay, that immediately tells me I'm not gonna have any holes. Because how do I get holes in my rational functions? How do I get holes? I cancel. And there's no factoring to be done, so there's not gonna be any canceling to be done. Ian, you feel okay, honey? Okay. All right, so I'm gonna jump right in then. There's really nothing else to do except jump in. So what can I put into my picture? What do I know? Horizontal asymptote would be at y equals 3, because how do I find a horizontal asymptote? I look right here, right? 3/1, perfect. What else do I know? Where's my vertical asymptote? Oh my gosh. At 1, x can't be 1. You guys are stressing me out. X can't be 1. I need my intercepts. How do I find a y-intercept? I let x be 0. And if I let x be 0, I think I get -6. And in order to get the x-intercept, I need this thing to equal 0, which means x would have to be -2. Isn't that the only way that fraction will equal 0? Based on that, can you generate a picture? That's what we're supposed to be doing. Whoops, I missed it, but it looks like that. And then, of course, where's the other piece? Gotta have 2 pieces here. The other piece is over here. Perfect. Abe, does that answer your question? All right, anybody else from a homework? All right, let's get out our review packet then. And there's a lot in here, but I'm gonna skip straight to page 7. You'll find the one that has a little 7 circle. Okay? Now, number 1 says solve using Gaussian elimination on your calculator. No way. That's just plain dumb. If you're using your calculator, we're not going to do Gaussian elimination. We're going to do Gauss-Jordan reduction. It's the difference between REF and RREF. Did we talk about that difference? Yeah. Okay. The deal is, folks, if you do Gaussian elimination, you're going to end up with a matrix that looks like this. Okay, so if I did number 1, the way it says, Gaussian elimination, type it into my calculator, this is what would come out. Now, what does this tell me? This tells me Z is 2, which is great. But then, to find Y, this does not tell me what Y is. So that tells me Y plus 5Z is 6. So I have to do work to find Y. I can do it, it's easy, but I have to. But if I'm pressing buttons on my calculator, I just want to RREF, because then all of these come out to be zeros, and then do I have any work? No, I have my answer. So I am not going to have you use Gaussian elimination. It's dumb on the calculator. Now, when we're doing them by hand, in honors, we do them by hand, then we definitely want to do Gaussian elimination, Cause it's a lot easier to get these than it is then to turn around and get these also. So, we're doing it on the calculator, it's gonna be all like number 2, so let's do number 2. It says method of choice, but we're doing Gauss-Jordan reduction. Alright, so Gauss-Jordan reduction on problem number 2. Gauss-Jordan reduction. Directions will say Gauss-Jordan reduction. So I write down what's called an augmented matrix. Alright, let's put it in. And everybody should be practicing. Nobody is too busy or too tired to participate. Second matrix edit. What are the dimensions of this matrix? 3 by 4. And then just put the numbers in. Gauss-Jordan reduction, that's the process we're doing. So we put in our augmented matrix. Second quit. Second matrix, math, RREF. Second matrix A. Oh my gosh. I hope I typed in something wrong. What does your matrix say? What's your top row? I got 1, 0, negative 1, 1.2, 1, 2, 1.1, 0, 1, 2, 1.4. Is this what yours looks like, or did I type in something wrong?
So,
Oh, good.
That's what mine looks like.
Oh, it does?
I got something.
Well, try it again. Some, we all should get the same thing. So it's possible, I put those numbers in pretty fast. So it's definitely possible I made a mistake. 1, 2, 1, 2, negative 1, negative 3, 3, negative 4, negative 7. 4, I think I'm right. I think I'm right. Why am I so bummed?
And they have to do math.
What?
They have to do actual math now.
Well, the whole bottom row disappeared.
Yeah.
How do I handle that? Who remembers? This happens sometimes. How do I handle that?
Just enter.
Look in your notes. What did we do? Variables are X, Y, and Z. The bottom row says Z equals Z. Oh, yeah.
You have to put them in the.
Yeah, I mean, when we get to that point, yes.
Yeah.
There is no unique solution. We had hoped that the bottom would come out looking like this and literally say Z equals 2, but it doesn't. It says nothing equals nothing. True. So we say Z equals Z. Now what does this next row say? What does that row say? Y plus 2Z equals 1.4? I do not know what Z is. So the best I can do is 1.4 minus 2Z. Y equals 1.4 minus 2Z. And then what does the top equation say of my new matrix here? The top equation says X minus Z equals 1.2. Remember, this is the equals line right here. So X equals 1.2 plus Z. Guys, this happened to us in our notes, remember? And then we gotta organize our answer. So I think Kara remembers. Kara, how does that look like when I try to organize all this?
It looks like a matrix.
All right, X, Y, and Z, that's my job, finding X, Y, and Z. And each of those, look at your X, has two parts. It has a number part and a Z part. So the number for X is on top, 1.2, and the Z coefficient is 1Z. And then Y is 1.4 and negative 2 Z's. And then what's Z? Don't get tripped up. It's easy. What's Z? What's its number? 0. And there's one of them. So 0 plus 1Z, and that's called the general solution to the problem. Okay? How did I know I was gonna have to do all that? Right here, this is not what it's supposed to look like, kids. That's not what it's supposed to look like, but that's how it came out. And this is how I deal with it. Now, let's go ahead and do the first problem with Gauss-Jordan reduction. I hope it has a decent answer. I want to do one that's got a decent answer. So, for Gauss-Jordan reduction, again, I'm changing the direction. Gauss-Jordan reduction for problem number 1. I'm going to do exactly what I just did, only this time I'm putting in these numbers. Wait, is that what I just did?
Yeah.
Okay, let's do problem number 2 then. That's what I meant to do, problem number 2. All right, so I did problem number 1 with Gauss-Jordan reduction. Now I'm doing problem number 2 with Gauss-Jordan reduction. Okay, so let's see what happens here. Hopefully something decent.
Yes.
Is it good?
Yeah, great.
Great.
I hope so.
I know.
Oh my god. It's really that great? Yeah. Jeez.
All right, here we go. Oh, yeah. Talk about a plan, Greg.
Yeah.
Yeah. So this one came out exactly as we had hoped. And not only that, but the answer to the question is 1, 2, 3, right? X is 1, Y is 2, Z is 3.
Oh yeah.
Everybody okay? All right. Take a look at number 3. There's a whole string of stuff to do there. We only have 10 minutes, so look at that list. Which one shall we practice? A? Problem A says add 1, negative 1, 2, 3. This is problem A, which says take matrix A and add 2 B's. So 2 B's would be negative 2, 10, 12, and 14. Is that good with everyone? And now we just add entry by entry. So here we go. 1, negative 2, negative 1 and 10, 2 and 12, and 3 and 14. There you go. Now, are there problems that you wouldn't be able to do? So, for example, if I said add A and C, you would say can't do, because the rules for add are they have to be the same size, right? Same dimension. Okay, what else in that list? We did A, what else? C? C said, oh, can't do it. C says, find the inverse of C.
Oh, it has to be square.
It has to be square. In order to find an inverse, you have to find the determinant. And you cannot find the determinant if the matrix isn't square. So C is impossible. Problem C is impossible. All right, what? B, yep, we already did one of these though, Kara. We're finding the inverse. How do we find the inverse of a matrix? Find the determinant of the original, which would be negative 37. Abe, please. Then we're going to take our original matrix and make some changes to it. So we take these two and flip them. Take these two and make them negative, right? And then take each of those and divide by negative 37. Simplify anything that simplifies, and that's the answer to the problem. Negative 737. So there it is. If we were solving a system with the inverse, like we did earlier, then we would take that matrix and multiply by the constants, and that would be the answer to the system. But we're just finding the inverse here. All right, what else from the list?
J.
J. J, that notation, I normally use a capital T, but some textbooks use a lowercase t. It doesn't really matter. If it's a T that's up above like that, that means transpose. And what does it mean to transpose a matrix? Yep, oops, not quite that narrow. Means the rows become the columns and vice versa. So, row 1 would be negative 1, 3, 2, 0, 1, 4. So whatever the first column was in the original matrix, it's now going to be the first row. Whatever the first row was is now going to be the first column. No work to do there, just write it down. All right, what else? Anything else from number 3? Huh? I says multiply C times B. Before I write it all down, I want to make sure I can even do that. What are the dimensions of C? 2 by 3. What are the dimensions of B? Can't do it. Because what's the rule for multiplication? The inside has to match, so that would not be multipliable. All right, I want to skip down. We've done one like 4 and 5 and 6 already today. I want to skip down and do number 7 because this kind of problem for some reason sometimes gives us issues. So we're solving this system. And there's no directions about, you gotta do this or gotta do that, you can do anything you want. So, what do you wanna do with this? Oh my gosh. What do you wanna do with this? We could definitely substitute. I would probably, maybe, I mean, I don't know, what do you wanna get by itself? Either this X or this Y, which one do you wanna get by itself? Top Y. So Y equals 7 minus 2X. And then I'm gonna plug that in right here. So X plus 7 minus 2X squared equals 4. If we do substitution and we choose to get that Y by itself, then this is what our equation looks like. Right? So now we're gonna FOIL that out. That's a FOIL. So we're gonna have 49 minus 28x plus 4x squared. So now it looks like this. What kind of an equation is that? Quadratic. So we're gonna clean it up and get it set equal to 0 and then figure out how we're gonna solve it. So I've got 4x squared minus 27x plus 45. I don't know, how does that look? Does that look okay? All right, now what? you can use the quadratic formula. These numbers are kind of big, so we'll need a calculator if we're gonna use the quadratic formula, I think. I mean, these are big numbers. So our other choice is to factor it. I don't know if that factors or not. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh my gosh, it did factor. So we got 27 plus or minus 3 over 8. This works out to be 9. So this thing did factor. But we didn't, so it's okay. So what are my answers? X is gonna be what? 27 plus 3, which is 30 over 8, which is 15 over 4. Or x equals 27 minus 3 over 8, which is 3. Now your pencil go down. We are not done because our answer has to be x's and y's. So one of our x's is 3, one of our x's is 15/4. Then how do we find y? Plug it right back in. So if x is 3, that's easy. I get 1. If x is 15/4, I get 7 minus 15. Oh no, 2 of those. Negative 1/2. Yep, that's exactly right. Negative 1/2. Perfect. And those are the answers to the question.